We learned a lot about the addition of two vectors, and now let's learn of a practical question based on that. The question is saying two forces 20 Newton and 5 Newton are acting at an angle of 120 degree between them. Find the resultant force in magnitude and direction. Cool. So the question is saying we have two forces. Let's say this is force 1, all right? And force is a vector quantity. Let's say this is force 1, this is 20 Newton, and another force is 5 Newton, all right? 5 Newton force. Let's say this is force 2. All right, and why did I make like this? Because the question is saying the angle between them is 120 degrees. So this is 120 degree between them, which will work as a theta in my formula. Well, to solve this question, my dear friend, you can solve manually also, as in the parallelogram law we did, or triangle law we did. In the same way, you know, by extended you can do, or directly you can use the result of the triangle law or parallelogram law. All right, so here I'm just going to use the direct way. All right, directly, you know, formula I'm going to use. The resultant formula from the triangle law we had learned is, you know, the resultant of this force 1 and force 2. According to that, it will be F1 square plus F2 square plus 2 times F1, magnitude of F1, times magnitude of F2, times cosine of angle between F1 and F2, and these all are inside the root. This is the formula based on that. All right, here R represents the resultant of this. Okay, later you will come to know that the resultant is going somewhere like this. All right, this will be the direction of resultant, how this is how it's gonna work, and in future we're gonna get soon. All right, so F1 is how much? This is F1 square is actually, you know, the magnitude of F1 whole square, and this is also magnitude of F2 whole square. You know, I mean to say F1 is representing vector 1, let's say vector, but when I do like this, it represents the magnitude of that, and when I square this, I can simply write like this also. So that's what I had written initially, F1 square. All right, so now F1, the value of F1 is 20 Newton, so it's going to be 20 square, and F2 is 5 square, and now plus 2 times F1, again 20, again 5, and cosine of angle between them is 120 degrees, so cosine of 120 degree. Cool. Now 20 squared, that is 400, 5 squared, that is 25, and 2 times 20, that is 40, and 40 times 5, that is again 200, and cosine of 120 degree is equals to minus half. All right, you should know the trigonometric table. All right, that is always required in physics. You should know, you should be very good in trigonometry, calculus, derivation, you know, antiderivative, I mean integration. These are very basic things. So this is going to be 425 plus 200 times 1 by 2. Let me make it negative, so this will cancel up with 100, so I'm gonna get here 325 inside the root. I'm poor in calculation, so I have to use my calculator, and under root 325 is giving me 18.02. all right, it's 18.02, or better I can write 03, okay, Newton. So the resultant, the magnitude of the resultant, we got it. All right, if one force is acting 20 Newton like this, and another force is acting 5 Newton towards this, then the resultant will have the magnitude of 18.03 Newton. All right, but what will be the direction? All right, exactly direction we don't know. So for a while I'm supposing that the direction of this resultant is, let's say, given by beta with respect to force 1. Okay, so again I'm going to use the formula that we had derived in triangle law of vector addition. You can find the video about the vector addition as well as parallelogram law of vector addition, derivation, all the things you can find out in this playlist. All right, I'll try to put somewhere links also if possible. Okay, so according to that, beta is tan inverse q sine theta divided by p plus q cosine of theta. It's theta, right? Okay, so tan inverse, now q is here, this will work as a p, this will work as a q. All right, I mean this is f1 and this is f2, so it's f1 is here. Better I will write this as f1 and f2, don't get confused. All right, this is f2, this is f1, this is f2, so f1 sine theta. So here f2 is 5 Newton, all right, and sine theta, that is sine 120, divided by f1, that is 20 Newton, and f2 is 5 Newton, and cosine of 120, and these all are tan inverse. So again, tan inverse 5 times sine 120 is absolutely root 3 over 2 divided by 20 plus 5, and cosine of 120 is absolutely negative 1 over 2. So let me solve further. So it's going to be 5 root 3 divided by 2 times 2 will go up and it will be 40 minus 5. All right, so this 2 and this 2 will cancel up and you'll get, and this will cancel up by 7. So it's tan inverse root 3 over 7, and it's going to be now further tan inverse. From the calculator I'm getting this as a 0.24, and further I'm using calculator as a tan inverse 0.24. I'm getting 13.89 degree. Okay, so the resultant is making here the angle of 13.89 degree with respect to the first force with the magnitude of 18.03 Newton. All right, so this is how, when a force is acting 20 Newton and 5 Newton force by making an angle of 120 degree, then the resultant will be of magnitude 18.03 Newton with the angle of 13.89 with respect to first force. All right, this is how we have to solve a very simple type of the question based on the triangle law of vector addition or simple vector addition concept. All right, we'll be doing lots of problem, lots of concept we're going to learn in further videos, so keep on watching. I'll be right back in the next video. Bye bye.